What's up, guys? There may be times when you wonder, where did I come from? Maybe you should try going up to your parents and ask, Mom, Dad, where did I come from? But if you have to ask yourself, where did I come from? Where did everything come from? What is the origin of existence before you spiral into an existential crisis? Perhaps we could discuss the origin of the universe. Welcome, Science Fam. My name is Sir Ramon, and this is Science with Sir Ramon. Let's get right into it. First things first, what's this thing? It's a burning giant ball, and perhaps you're familiar with it when you stare up into the sky if it's day and you see a big ball of giant burning eye-ness. That's called Sol. It's our sun, and it's the star of our solar system. What about these things? What are these balls for? Let's get rid of my face. So here we have what is recognized as Earth. We have here Mars and other planets. These are basically your terrestrial planets. They have a solid rocky surface. They have a structure similar to Earth, a core, a mantle, and a crust. What about these four? If the others were terrestrial planets, these, you might have learned, were gas giants, but they're better known as the Jovian planets. They're the big Titan-like planets on the outer reaches of our solar system. They're much larger than Earth, and they're composed of what we call supercritical fluids, which means that it's not just gases, solids, and liquids. Supercritical fluids are another state of matter. So up next, what are these things? So these things, numbering more than 100, are called Messier objects. They're a list of Charles Messier's frustrations. So these are things you can see using binoculars or a telescope in the night sky. And Messier is a French dude who just wanted to see some comets. And since he wanted to see some comets and they're quite hard to see, he had to list down everything that wasn't a comet but looked sort of like a comet in the night sky. And because he used things that are about as powerful as binoculars or telescopes in modern times that are easily accessible, amateur astronomers like identifying the objects that he didn't want to see as things that are nice to see. So, ironic, isn't it? And there's a lot of irony in these things when they concern the universe, because we are obsessed with the night sky and what lies beyond our little blue marble of a planet. So our topic is the universe and the solar system. And what are our goals for this topic? We want to differentiate all the approaches to understanding the origins of the universe and the solar system. We want to discuss the fate of the universe and the solar system. So we're going to look at existence and how everything will end in this topic. 1 week, the beginning and the end. Let's go. So first off, we need to discuss what exactly we mean when we say, what is the universe? Okay, so specifically, what is an observable universe? So when we say universe, it's basically everything, all of space and time and everything in between. That's the universe. But that's a bit vague. Like, how do we know if it's a thing or not a thing? Let's leave that to the philosophers. In science, we stick to what we can observe. So let's talk about the observable universe. It's basically the detectable region of the universe. So the universe, most energy can be detected as electromagnetic radiation or EM radiation, and this travels at the speed of light. And EM radiation that has had enough time to reach the Earth would constitute the edge of the universe. So imagine, since the dawn of time, the universe has been expanding and so on, and EM radiation has to have had enough time to reach the Earth so that we could observe it. Like if light bounces off of something, it needs time to reach your eyes again. Okay? So again, the observable universe, it's limited by what literally we can observe based on the speed of things we can observe. But how did it begin? What is the origin of existence in the universe? So we'll go to one of the oldest books that we have. Wait, before that, we have a series called The Big Bang, or the Big Bang. That's a series. So its opening theme basically describes the most popular theory for the beginnings of the universe, the Big Bang Theory. So supposedly, it all started with nothing. In the beginning, darkness covered the face of the deep. That's the book of Genesis 1:1 to 2. So even in the Bible, again, there's a theological approach to beginnings of the universe, and that's not necessarily that far off from what we have in our scientific theories. So from the beginning, okay, in the beginning, like before anything, time and space did not exist. This is the literal big B, before, like before everything. There is no is, there is no be. Okay, before any state of being. Okay, time and space did not exist. Wild, right? Can't even imagine it. What's this speck? What's that symbolize? Okay, let there be light, it was said. And there was light. Genesis 1:3. Okay, so this in the theory of the Big Bang is called the initial singularity. It's an infinitely dense point which contains all the energy in the whole universe, and it's so hot, there's so much energy that particles can't even begin to exist in that tiny, tiny point. And now we have this. It's not a tiny point anymore. This. Okay, according to Genesis 1:6, let there be a dome in the midst of the waters, and let it separate the waters from the waters. Separate the waters from the waters? What does that mean? Alright, so let's talk about this in the context of the Big Bang Theory. We have the cosmic inflation. It's the exponential growth in size of the little tiny dot of the singularity. So there was a separation between what isn't and what is. So that inflating thing is the universe, and what is beyond it is what is not. Wild, so philosophical. And because of this cosmic inflation, this expanding of the space, the energy was distributed in that space, allowing for enough cool down for elementary particles to occur, the fundamental particles of matter. So these are the basic elementary particles. We have two main categories. We have the fermions, which constitute matter and antimatter, and we have bosons, the force particles. So for matter and antimatter, they can be segregated into quarks and leptons, and antiquarks and antileptons. Of course, those correspond to matter and antimatter, respectively. With your bosons or your force particles, again, if we think of force as having a particle, you can classify them as gauge and Higgs bosons, and they also include photons and gluons, all lots of fancy sounding scientific terms, but the most important thing is that we have fermions, the actual stuff, and bosons, our term for particles of force, the oomph, the energy. Okay, so matter and energy. Moving on. Now, in that big inflating thing, we have spaces in between. What happens there? So the light was good, and it separated the light from the darkness. Genesis 1:4. Okay? So there is an event called baryogenesis in the Big Bang Theory. It's supposedly the cause of what we call baryonic asymmetry. It just means that there's more matter than there is antimatter. See, matter and antimatter tend to collide with each other and cancel out. Again, it's a common thing in pop culture and science fiction that matter and antimatter, when these two particles collide, they just cease to exist. Now, the baryonic asymmetry just says that there was just a bit more matter than there is antimatter. There's a tiny fraction of matter left over, and everything that we see and can interact with, the matter that we have left over today, is the result of that tiny leftover. Okay? Again, that single tiny bit of asymmetry between matter and antimatter, that's what is left in the universe. And now we have this. What are these? Let there be lights in the dome of the sky to give light upon the earth. Genesis 1:14-15. So this is related to the cooling phase of the Big Bang Theory. Because there's less energy, more complex matter can form. Again, Einstein's theory of relativity, matter and energy can be correlated. When energy can be transformed into matter, so the complex matter resulted in the formation of the first stars and galaxies in the universe. So now things are getting complicated in the universe, but that's just one theory. Again, the Big Bang Theory is the most well-accepted and well-known, but there are other theories for the origins of the universe. Let's go through them. So one of the theories is, what if there was no single point, no singularity at the start? Okay? So Stephen Hawking, renowned scientist that he was, proposed just that what if there was no single point that marked the beginning of space and time? What? So Hawking, along with another scientist, Hartle, proposed the no boundary theory. So there's no boundary because there's no single point. It's pure time. So it results in a shuttlecock shape. Instead of a single point that expands, there is literally like an asymptote where there is no space. It's just pure time. Okay? So it implies that there's no beginning. There's no actual beginning. It did not flow as we perceive it to be, that 1 second is what comes after the next second and comes after that and so on and so on. It's not linear. There is a point where time did not flow like it does now. Okay? And so there is no beginning. So what does that mean? Ask Hawking when we get to meet him. So again, it did not flow until inflation happened. Only when inflation, cosmic inflation happened, did time flow in the way that we perceive it. So actually, this no boundary theory is similar to Buddhist ideology. In Buddhist ideology, there's no point in asking what the origin of the universe is, because asking that question doesn't help people get to the state of nirvana. So sometimes we just shouldn't get caught up in our origins and our beginnings, because what we should be caught up in is reaching the best end. Try explaining that to kids when they ask you where they came from. So some dude, some guy had the nuts to say Hawking is probably wrong, and that resulted in another theory. Okay? So for this presentation, it's a 2D projection for you guys. You just have, you know, the box, the height and the width of your screen. But you yourself as a person, as a thing, you live in a 3D space. You can go forward and backward, aside from up, down, left, and right. So there's a 3-dimensional space. So if there's 2D and there's a 3D, okay, you can manipulate 2D objects because you're a 3D entity. So I can manipulate things as a 3D entity, like I can move this square of my face wherever I want it in ways that cannot be understood by a 2D entity. What that just means is that there's an implication. What if our 3D space-time can exist in a 4-dimensional dimension? So things that we cannot perceive, movement that we cannot perceive, can be done by a supposed 4-dimensional entity in the 4-dimensional realm. Okay? So this theory, mind-blowing, but it's the cyclic brain theory proposed by Steinhardt and Turok. And this dude above me is Neil Turok. He helped Hawking do the math for the no boundary proposal. Then he turned around later on and said, perhaps there's another way. Okay? So he worked it out with Paul Steinhardt for an out-of-dimension theory called the cyclic brain theory. In this theory, okay, there is basically a brain, a membrane, a sheet, and that sheet is the universe, the plane of the universe, the 3D sheet of the universe, and the bulk is the 4-dimensional space. Now, in the cyclic brain theory, supposedly the 3-dimensional sheets of different universes float around in the bulk, and it's possible for them to collide with each other. It's like, okay? And when they collide with each other, there's enough energy there for what we perceive as a Big Bang. Again, let's slap those brains together, there's enough energy for a okay? And when the brains move apart, they then drift back and collide again. That's why it's the cyclic brain theory. They hit each other, they drift apart, and then they drift back and hit each other again. Okay? It's a circle, it's a cycle. Okay? So again, the cyclic brain theory explains some of the things in the Big Bang theory, but in this case, it melds everything together into a big bounce. And if you can see here, it's also kind of shuttlecock shaped, but now there's 2 shuttlecocks, there's 2 belts on both sides. So we have repeating ripples of space-time in 4 dimensions, meaning the brains or the sheets of the universe, the 3D sheets, just keep slapping each other repeatedly. Just slap that again and again. Okay? And every time it slaps, that's a Big Bang. And every time they drift back together, that's, you know, the heat death of the universe, the implosion of that 3-dimensional universe. And so it's a cycle of the same matter just going womp, 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 womp. Okay, that's the cyclic brain theory in a nutshell. And it's actually similar to another belief system, the Hindu ideology. For Hindus, this is just one of many parallel universes, and there is a cycle of chaos and birth from chaos. Order, chaos, rebirth. Okay? But how do we know that this is all real? Okay? How do we know that this universe isn't just some sort of game where we're all being controlled by a player character or we're all NPCs? So there's a hypothesis called the simulation hypothesis where everything is just a simulation in some giant computer that's being run by some guy who wanted to make a universe. Now it's very nihilistic. Ask Sir Gian about that, your philosophy professor. So again, nihilism, it's like pointless. It's like nothing you do actually affects any real thing because you're just a simulation. So if this hypothesis is real, then even scientists say it's best not to find out because that'll just mean everything is meaningless, and whoever's running the simulation, when they realize that we've reached sentience, is going to say, I should probably turn off the simulation, and thus ends our universe. Okay? So don't go asking whoever made the simulation to recognize us. Anyway, the point, there are many perspectives. There are many approaches to understanding the origins and how the origins of the universe and how it works. It can be scientific, it can be philosophical, it can be religious or ideological, but it all amounts to one goal. It's to understand. It's one of the big questions that we always ask ourselves: where did we come from? Okay? And it's very difficult to find out the actual answer. What we're left with is all of these theories. Now, your mind must have been blown by now, so we're going to take a breather before our second video, which will focus on the origins of the solar system this time. We're going to scale it down to just our solar system, right? So I'll see you guys next time.